All right, this is going to be called 9.2 Part 2. It's a factoring out the greatest common factor. If you look at this page of notes, there's basically three steps. First, to find the greatest common factor of each term, which we'll talk about on the previous page. Dividing out the greatest common factor for each term, or multiply what's left over. I'll go over that on this page, so it should make sense. And then rewrite as a product, numbers need to be multiplied. You put the greatest common factor out in front of the parentheses. So let's go to this page and talk about, first of all, finding the greatest common factor. The first step is list the prime factorization of each term. Prime factorization. So we basically do that factor tree and look for all the prime numbers that are only divisible by 1 in itself. And then we identify all the factors that are common or the same in all terms. All right, so for example, this is how we're going to set this up. If we look at this polynomial, we have three terms. We have a 4x to the third, a positive 12x squared, and a negative 8x. Don't worry about the positives and negatives. We're just going to look at the terms for right now because we're just looking at what a common factor is. So if you do your factor tree, so if we did 4, we got 2 and 2. We do 12, we have 2 and 6, 2 and 3, and we do 8, we have 2 and 4, 2 and 2. So that's a review on the factor tree, how we do that. So 4x to the third, we have 2 and 2, and then we have 3 x's for that x to the third. 12, we have the 2, the 2, and the 3, and the 2 x's, and 8, we have 3 2's and the x. So when you look at it, I tried to bold these, but we have a 2 and a 2, and then 1 x that's in common of each term. So when we multiply those back together, 4x is our greatest common factor. Now you're going to want to list them out like this for when we do the next part about factoring them out, because there's an easy way to do it. So try to do it like this for these examples. So for these, we're just finding the greatest common factor. So I'm going to list out 5v to the fifth and 10v. 5 is already a prime number, so we have 5 and then 5 v's. 1, 2, 3, 4, 5. 10, if you remember, is 2 and 5. Those are both prime numbers. So our prime factorization of 10 is 2 and 5, and then we have 1v. Normally you put little dots in between these because they're all being multiplied, but I'm just going to leave them separate. So when we look what's in common, we have a 5 that's in common in both, and 1v that's in common. So our GCF here would be just 5v. So that's the answer to that one. Over here, we're going to write out the prime factorization of 3x squared and an 18. So 3 is already prime number, so it's just 3 and 2 x's. And 18, let's go ahead and figure that out. So we have 2 and 9. I always start with 2 when we have an even number, just because we know that 2 is a prime number. It's the only even prime number we have. 9 would be 3 and 3. And remember, you just keep dividing that by numbers until they come out as whole. So this would be 2, 3, and 3 is our prime factorization. I'll put the dots there just so you're not confused. And then when we look at what's in common, you can see we have a 3 in common in both. So for this, our GCF is just 3. Can't use a variable because there's no variables in that one. All right, our final example for this. And pause this if you want to try it, go ahead. 4w to the third, 2w squared, 6w. So our prime factorization of 4 when we do our factor tree would be 2 and 2. And then we have 3 w's. 2 is already a prime number, so we just have 1, 2, then 2 w's. And then 6, when we break that down, 2 times 3, and then 1 w. So if you still need to do the factor tree, 2, 3, and you can see that, go ahead and do that. Going kind of fast here just because of the notes in the video, and you can pause, slow it down, rewind as you go. So as we look at these, we have to figure out what's in common. Well, they all have a 2, right? So there's a 2 in common. This has a 2, this is a 3 that's it there, and they all have at least 1 w in common. So that's it. These each share a w, but this one doesn't, so we can't count it. So my GCF for this one is going to be 2W. And that's it for that one. All right, so that's the first step of when we're taking out the greatest common factor or dividing out the greatest common factor in a polynomial. So now on the next page, that's going to be our first step, and I'm going to show you how that's going to look. You know, if you go back a few about how we multiplied, we went from here and made it look like that. We used this box method. But essentially what we're going to do now is take this and make it look like this. So we'll go back to this page of notes, and we're going to follow our steps. First step, take out the greatest common factor of each number. So if I look at this first example, I'm going to go ahead and list these out. So 3 is already prime, so we have 3, x, x, and x, 12. So we have 2 and a 6, 2 and a 3. So it's 2, 3, 2, 2, 3, and 2 x's. And then 15, 2 doesn't work, but I can do a 3 and a 5. So 3 times 5, and we have 1x. So if I look at what's in common, I do have a 3 in each one. So that's good. And I don't have a 2 in either of these. I don't have a 5, but I also have 1x in each one. So 3x, if there was more numbers, I would just multiply them at the end, or put a 3x squared if there was multiple x's. But in this case, that's all that's in common in all 3 of these. And this applies to if there's 4 terms, 5 terms, 6 terms. You can list it out like this. So the first thing is finding out our greatest common factor. So now that's going to be the number on the outside. And you can see here, step 2, it says divide each term. So I can take a 3x and divide a 3x out of each of these terms. But I think the easiest way to look at it is multiply by what's left over. So I'm going to put a 3x on the outside. So this 3x here, I'm going to end up with this. I'm going to put a parentheses. And now these signs are going to stay the same. I remember I told you kind of ignore those. But we're going to have 3 terms on the inside, and one's going to be a minus and one's going to be a plus. And we're listing them in this order. So if I look at what's left over from this, the 3x to the third, it's x squared. So I'm going to put an x squared there. I'm going to put that minus there because I'm going to keep those signs consistent. Now, what's left over from that middle term? We have 2 times 2, which is 4, times x, which is just going to give us a 4x. I'm going to put that plus down. Then over here, what's left over? We just have a 5 left over, and that's that. So that's it. Once you can find the GCF, it's pretty much the work's done for you. So most of the work is finding the GCF. So that is factoring out a greatest common factor. Let's go ahead and try these. I'm going to do these, but pause them. Pause the video. Try these on your own. If you're completely stuck, go ahead and watch, and we'll get through it. So the first step is to list out the GCF. So 8x squared, 12x. And again, I'll do my work on the side. So 8. And you'll get to know that 8 is 2 times 2 times 2 pretty quick, right? Because it's 3 2's. So my GCF of 8x squared is 2 times 2 times 2 times x times x. 12 would be 2 and 6, 2 and 3, so 2 2's and a 3, 2, 2, 3, and 1x. So if we look here, what's in common? We have a 2, another 2, and an x. So 2 times x would be 4x. Now that's going to be on the outside. On the inside, I'm only going to have 2 terms because it's just 2 terms up here, separated by a minus. So what's left over with our 8x to the second power is just a 2 and an x, so that goes there. And then what's left over at this bottom one? Just a 3. We put that there. Now if we multiplied this back through, distributed this back through, we would get our original problem. All right, let's try the next one. 5d to the third, 10d. So 5's already prime, 5 and 3d's. Now obviously, if you get more comfortable with these, there are shortcuts. You might see that right away, oh, I can take a 5 out of a 10 and 1d, so I wouldn't have to go through this process. But visually, for you guys right now, I think this is a good starting point because it's telling you what's left over after we do that. So let's take a look at what we have in common. We have a 5 in common. We have a d in common. So 5d would be on the outside of our parentheses. And then what's left over? We have 2d's, so that would be d squared. because we're multiplying, not adding. It wouldn't be 2d, it'd be d squared. And there's a plus in that problem, so I'll do plus. And what's left over here? A 2, so put the 2 there. All right, pause this. Again, try this one on your own. But I'm going to go ahead and start doing it. So we have 6m to the third, 12m squared, 24m. So 6 is 2 times 3, so 2, 3, and 3 m's. 12, well, we've already done 12, so it's still up here. 2 2's and a 3. So 2, 2, 3, and then 2 m's. 24 we haven't done yet, so I'm going to go ahead and break down 24. Always do 2's, 2 and 12. Remember, you're just dividing by that number. 2 and 6, and we know what 12 is. 2, 2, and 3. So 1, 2, 3 2's and a 3. So that would be 1, 2, 3 2's, a 3, and then we have 1 m. So let's go ahead and see what we have in common. We have a 2 in common in all of them. We don't have a 2 in that one, but we have a 3. And then we have 1 m in common in all of them. So then I just like to look at the first one. 2 times 3 times m would be 6m on the outside. Now we're going to have 3 terms on the inside, separated by subtraction signs. So when we take a 6m out of an m to the third, what's left over? M squared. All right, and then we subtract. What's left over from this one when we took out a 6m? Well, here's our 6m. We have a 2 and an m left over. And then what's left over here? When we take out a 6m from a 24m, just 2 times 2, which would be 4.